Alright, today's topic is gravity and free fall. So what would happen if you dropped a baseball out of a second floor window? How would you describe the speed of the baseball at the beginning when you let it go and at the end when it hits the ground? So at the beginning when you let it go, it should be 0 because you're holding it, and when you're holding something it's at 0 speed. When it hits the ground, again it is at 0, but what happens in between? So is the speed of the baseball constant or does it accelerate? If it accelerates, at what rate? And do all objects fall at the same rate? So these are some questions that we'll be able to answer once we go over gravity and free fall. So an object is in free fall if it is accelerating due to the force of gravity and no other forces. So for example, a ball thrown upward is in free fall after it leaves your hand. After it leaves your hand, it is all due to gravity. So we say an acceleration due to gravity will accelerate downward at 9.8 meters per second squared. And we represent this with the letter G. So G equals 9.8 meters per second squared. Or sometimes you may say A equals 9.8 meters per second squared. But know that 9.8 is due to gravity. So it's acceleration due to gravity. So what does an acceleration of 9.8 meters per second squared really mean, and what is happening to the speed? So let's say, for example, you start throwing a ball off a cliff and your velocity is 0 meters per second. As gravity pulls down at an acceleration of 9.8 meters per second, okay, so if acceleration pulls down 9.8 meters per second, in 2 seconds that acceleration will double. 9.8 times 2, 19.6. Eventually, this would, of course, reach 0 again, right? Because it is going to hit the ground. So we can also describe upward launches. Again, if it's in free fall, it's 9.8 meters per second squared. Gravity causes the acceleration by exerting a downward force. So what happens if we throw a ball upward? So at point 1, it will slow down as it moves upward, and eventually at point 2, for a split second, it's going to stop, and then it'll fall back down again. So as it moves upward, the speed decreases by 9.8 meters per second every second until it reaches 0 at the top. Next, it reverses direction, it goes back down, and it falls downward again with 9.8 meters per second every second. So same here. So let's say for this example, this person is throwing the ball with a velocity of 19.6 meters per second. As soon as he lets it go, he has no force, no velocity on that. It's all that acceleration is due to gravity. So after 1 second, it increases by 9.8 meters per second. At 2, of course, it reaches a point where it has to stop at the top, so velocity is 0. And once it moves down, again, it goes down by 9.8 every second. So by how much does the speed of an object in free fall change each second? So as a ball is thrown straight up in the air, as it moves upward, its speed decreases by 9.8 each second. As soon as you let it go, acceleration takes over. As it falls back down, its speed increases by 9.8 each second. So any point that is not touching you, or it's not touching whatever source it's being thrown from, acceleration due to gravity takes over, and it's either going to decrease or increase by 9.8 based on the direction. So what is the difference between speed and velocity? We talked about this a little bit. And why does that matter? Because we're talking about acceleration due to gravity. And so we have to be able to use velocity and displacement here. So now let's do some calculations. So the rate of acceleration due to gravity is 9.8 meters per second squared. It's the same for all objects on Earth, no matter what. So we can use this formula to determine how far something will fall, and also how much time it's going to be in free fall. And so we have the formula here. Displacement is initial velocity times a change in time plus 1/2 times acceleration, change in time squared. So what? That's a really complicated equation, so we're going to break it down. So if you're given the time of an object that is in free fall, you can calculate how far it fell. So let's say, for example, you time how far it took for a ball to fall. Well, if you didn't have a long meter stick, you could calculate how far it fell based on how much time it took. Well, let's say you are given the height. Let's say you do know how high you are. Then you can calculate how long it'll take to fall. So let's make this formula easier to use if a free-falling object is at rest. If you're at rest, that means my initial velocity is 0. That means that on this equation I can cross this out. And so anything 0 times anything, this could be any number, is going to be 0. So that's why I can cross all of this out. And so I'm left with d equals 1/2 at squared. So let's say you drop a ball from the edge of a cliff. It lands 4 seconds later. What distance does the ball fall during the 4 seconds? So I have t equal to 4 seconds. My initial velocity is 0 because we were dropping it from a cliff. We were holding it or something. Distance, I don't know. That's what I'm trying to figure out. And a is equal to 9.8 meters per second squared. So we use our formula. D equals vi times time plus 1/2 at squared. So let's plug in our numbers. So we know our initial velocity is 0. That means I can cross this section of the equation out. So we're left with d equals 1/2 9.8 4 squared. So we simplify this. 1/2 times 9.8 is 4.9. 4 squared is 16. We multiply that together. We get 78.4 meters. So that's how high the cliff was. Example number 2 here. A stone tumbles into a mine shaft and strikes bottom after falling for 47.3 seconds. How deep is the mine shaft? So first of all, with these problems, just by reading the problem, you can tell what your answer could be, right? It fell for 47.3 seconds before you heard anything. That's a really long time. If you're sitting there listening to something and it takes 47 seconds, that is a long time. So we are going to determine that shaft is actually very deep. And so my variables, I have t equals 47.3. My initial is 0 because it's something falling. I don't know distance, and I have acceleration is always equal to 9.8 meters per second. So we use our formula, and we know that initial velocity is 0, so I know that I can automatically cross that out. And we have 1/2 at squared. So we simplify 1/2 to 9.8 times 47.3 squared. 1/2 times 9.8 is 4.9. 47.3 squared is 2,237.29. And finally, we get that the mine shaft is 10,962.72 meters deep. That is a very large number, just like we had predicted. A climber dropped her compass at the end of her 240-meter climb. How long did it take to strike the bottom? So 240 meters is pretty tall, so it might take a while for it to fall. And so our variables are t equals, and question marks, we don't know, that's what we're trying to figure out. Initial velocity is 0, my distance is 240, and my acceleration is 9.8. So we plug this in. Luckily, initial velocity is 0, so we can cross that out in our equation. This time we do have distance on this side, and we have 1/2 9.8 t squared. We don't know what t is. So we simplify. 240 equals 1/2 9.8 t squared. 1/2 times 9.8 is 4.9. So now our objective here is to get t by itself. So to get t by itself, I need to divide both sides by 4.9 so I can get t by itself. And so we have that here. So now we have t squared on one side and we have a number on the left. So how do we get rid of a square? Well, the opposite of a square is to square root. So I'm going to square root both sides. And so I'm going to be left with t on the right and 7 on the left. So it took 7 seconds. It didn't really take too long. So that means our compass, of course, was light. And that's why it didn't take too long. So a tennis ball is thrown straight up with an initial velocity of 20.5 meters per second. It is caught at the same distance above ground as it is thrown. How long does it take for the ball to reach its maximum height? And how high does that ball rise? To determine how long it takes for the ball to reach its maximum height, we find that we have our final velocity, which is negative 20.5 meters per second as you're throwing it up. And our initial velocity is 0. Acceleration is negative 9.8. And the reason it's negative 9.8 here is you're going against gravity. When we say something's accelerating due to gravity and it's positive 9.8, that means it is falling Okay, but if it's going towards up, it's falling up, then it's negative 9.8. So first, we use our acceleration formula to find time. So A equals VF minus VI over T. We plug in our numbers. Okay, another way to rewrite this, so we can see the algebra is negative 9.8 equals negative 20.5 minus 0 over T. And so the next step here would be to cross multiply. So I have negative 9.8 equals negative 20.5. So to get T, we have T here. So to get T by itself, we have to divide both sides by negative 9.8. And so T is equal to 2.09 seconds. So now we have time. So now we can calculate how high the ball rises. So our initial velocity is again 0, and acceleration is still negative 9.8. And so we use our equation for displacement to find out how high it went. Well, we know our initial velocity is 0. When we multiply it by time, it's going to give me 0, so I can cross this out. And we have 1/2 negative 9.8, 2.09 squared. And so our distance here, negative 9.8 times 1/2 is negative, we should have a negative here, 4.9 times 4.37. That would give us, our distance is negative 21.41. That was how much change there is in distance.